but it lowers the freezing point. So it melts.
Oh my God, how cool is it that my first post of 2024 is a Stitch with Elise Myers, and we get to talk about some really cool science. This is all about like what I thought about when I was an undergrad, and I've been thinking about ice and ice physics and ice nucleation for decades. And she asked an amazing question. It's a mind-bending question, and that is, why is it that we add salt to the roads to melt the ice on the roads, but we also add salt to the ice when we want to freeze ice cream? And that is, if you start to think about it that way. But the thing is that we really don't think about water, H2O, in the right way. We don't talk about it in the right way. And so we have some misconceptions. First of all, when we say below freezing, we're basically saying below 0 degrees Celsius. That's not a real thing. We're actually below melting is what it is. The melting point, the phase change from a physical form, ice, to liquid form, water, is at 0 degrees C. And there's an equilibrium there. So at 0, a molecule is just as likely to melt as it is to freeze, and it just sort of lives there. And so any temperature swing either direction, and you can push whether you're going to be more frozen or less frozen at any given time. But to nucleate, to actually start the freezing process, pure water has to be at something like minus 40 degrees Celsius. And just for context, your freezer, the freezer at your house, is at minus 20 degrees Celsius. So if the freezing temperature was actually at 0 degrees C, then you wouldn't need to have it at minus 20. You could have it at like minus 3 or 4, and you could save a lot of energy. But it's not, because the melting point is at 0, not the freezing point. So when we say below freezing, we're actually not saying the right thing. We should say below melting, but we don't, because, well, that doesn't make as much sense. But here's what salt does. So salt is all about changing the melting temperature. So at below 0 degrees C, if you have salt water, it'll still be in liquid form. And that's the point. It's where is water liquid versus where is water solid? Where is it liquid versus ice? Water versus ice, right? And so when you add salt into a system, it actually lowers the melting point so that water is melting or liquid at a colder temperature. So what that means when you add salt to the road is that it has to be colder in order for ice to form on the roads, which is why it's more liquid, because the ice is going to, or the water is going to exist as a liquid even when it's colder. And everyone who lives in the frosty Northwest or Midwest knows that there's a point at which you just have salty ice, right? It's just too cold, because there's no amount of salt that's going to fix that, because the need to freeze because of the temperature and the way the water molecules need to order, that's going to be a thing. Anyway, so the idea here is just to lower the melting temperature enough so that the water will stay liquid at a colder temperature. So that's how we stay safe on the roads. Now, why do we use this for ice cream? Well, so the cream is at a warmer temperature, and what you want to do is you want to bring the temperature down. Now, you want to bring it down to the temperature of the ice, actually, but air and ice are really terrible conductors of temperature. So if you can drop the melting temperature so that you have more liquid, the liquid, ice cold, really below freezing liquid, is now a better conductor of that temperature, and it's going to get into and start making the ice cream colder, the cream colder, that will eventually become ice cream because it wants to also start to freeze. And there's a paradox here, which I absolutely love, which is that the more impurities you put into the water, you can actually change the freezing temperature, so the freezing temperature can climb up and it's not minus 40 anymore. And it's a really cool problem. Ice and water is a really cool problem. But anyway, I'm sure that I got off topic. Now, what was Elise saying? Oh yeah, so she wants to know why we add salt to the roads and to our ice cream. And we add salt to the roads because we want liquids. We want the water to be water at a colder temperature, and we add salt to our ice cream ice because we want it to be liquid at a lower temperature, at a colder temperature, so that the temperature can translate into the cream and make it ice cream. Anyway, I hope that helped.